Okay, we are on chapter 7, energy of a system, and we're going to have a brief intro, just the first three slides. So let's share the PowerPoint. We're talking about energy of a system. Um, we're going to use energy as here lately we've been using force to calculate problems. Now we're going to use energy, in particular the conservation of energy. Energy cannot be created or destroyed, and we can use this conservation of energy principle to solve problems. And sometimes we'll use combinations of force and energy. First, we have to define a system. Valid systems are, it may be a single object or particle, it may be a collection of objects or particles, it may be a region of space, such as the interior of an automobile engine combustion cylinder. Um, it may vary with time in size and shape, such as a rubber ball, or which deforms upon striking a wall. All of these are valid systems. Um, okay, here we have, I should have had my notes up. Um, Here we have a system that is uh, a weight, the ball, M1. We have a pulley, we have a string, and we have a block of wood, and we have an inclined plane. So you have the combination of the ball, block, and cord are the system. And influences from the environment include the gravitational force on the ball and the block, the normal and friction forces on the block, the force exerted by the pulley on the cord, and then uh, the forces the forces exerted by the cord on the ball and the block are internal to the system. It's not included as influences from the environment. So this is an example of a system. We're gonna if you did the Atwood machine experiment, that was a system. You had a descending mass and a ascending mass, and that was a system. You were using that system to uh, calculate or do studies on Newton's second law. Okay, that's our short intro.